Hey everyone, I'm Scott Ammon. I'm a senior software engineer at Slalom Build. My day-to-day work revolves mostly around modern web and cloud-based solutions for our clients. But I'm here today to talk to you about my personal hobby, music. I'm a drummer, and I love finding ways to merge music and software, which brings me to today's talk about connecting electronic musical instruments to the web. So why music and the web? I've been a drummer since I was a little kid, but when I moved away from home, I couldn't bring a loud drum set into an apartment with me, so I got into electronic drums and keyboards. These electronic instruments allow me to easily record into my computer using something called MIDI. So what's MIDI? MIDI stands for Musical Instrument Digital Interface, and it's a technical standard describing how electronic musical instruments, computers, and other audio interfaces can communicate with one another. So it not only specifies the communication protocol, but also the physical connectors themselves. It's really important to note that MIDI doesn't transmit audio. It's just transmitting data that represent the physical actions that were performed on an instrument. So I thought, hey, there's got to be a way to connect these MIDI instruments to the web. And that led me to discover the Web MIDI API, which creates a JavaScript interface between these electronic instruments and the browser. So the Web MIDI API is a relatively low-level interface, meaning it doesn't implement device-specific details like the number of keys on a keyboard. But we'll see that despite this, it's still pretty simple to get started connecting our instruments. So here's a sample MIDI message coming from a connected keyboard that I've hooked up. So the data key is the part that we really care about because it represents the physical action that occurred on the instrument. This first element in the array here represents the type of the event, which in this case was a note-on event, meaning a physical key was pressed on the keyboard. 144 here represents the decimal representation of the raw MIDI byte that we received, but we don't have to worry about that because that implementation is abstracted away from us in the API. The second element in the array represents the actual note that was pressed, which in this case was middle C. So if we were to press the next note up, C sharp, that would be 63, and so on. The last element in the array represents the velocity, or how fast the key was struck, which typically correlates to how loud the sound is, depending on whatever audio generating software you're using. So now that we understand what the API handles, let's build some fun stuff. The first project, mimicking a MIDI keyboard in the browser. So I drew this keyboard using HTML and CSS, and when I press the physical keys on the actual keyboard, we're going to mimic that behavior in the browser by dynamically adding some CSS to make it appear as if these keys are being pressed. So we've got the keys, we've got a pitch dial, which is going to warp the frequency of a note up or down, and then we have a modulation dial, which adds sort of an oscillation or vibrato effect. The keyboard itself just connects to my computer using a standard USB cable. There's no special audio interfaces needed. So from a coding perspective, I used React, but you could use any framework or just plain old vanilla JS and build all these tools just the same. I used React's context API to pass the MIDI data down to components. If you're not familiar with React's context API, it's React's way of passing data down the component tree without having to pass properties at each level. So that gives us a lot of flexibility here in building our components for the visualization. So I mapped the incoming MIDI data to these 5 separate categories here. And these represent the default values. So for example, pitch can exist in the range from 0 to 127. So 64 here is roughly the midpoint, representing the note at its natural pitch. So now that we have a way to pass this data to the components, let's see this visualization in action. You can see it has really low latency, so we get real-time feedback in the browser, which is great. So now that we're able to represent the keyboard actions in the browser, let's extend that to transmit this MIDI data over the web. So I took the keyboard setup from before and tweaked it slightly to allow the incoming MIDI messages to be sent to a WebSocket endpoint on AWS API Gateway. Then I built a few simple Lambda functions that are going to handle connecting, disconnecting, and sending MIDI messages. And then there's a simple database on the back end that's just going to store the ID of each connected user so that we can broadcast that MIDI message back to every connected user. So why is this great? It's relatively simple to set up and manage. Why is it kind of terrible? Well, because this serverless setup doesn't guarantee ordered message delivery, meaning the connected users might receive the MIDI data in a different order than it was transmitted. So a much better solution would be to set this up using something like a container running a WebSocket server, but this was an easy way to prove out the concept. So let's see a video of this in action. So you can see I've got 3 devices connected, and there's a slight delay between the data being received in each one. So now that we've taken a look at setting up a simple keyboard, let's work with the drums and build some cool visuals. So the drums are like the keyboard, but instead of the MIDI messages mapping to a specific note, they're going to map to a particular drum or cymbal being struck. So to make the visualization, I chose to set up render methods that are going to return SVG elements to the screen. So on screen here, you're seeing a simple line being rendered each time the hi-hat is struck, which is the pair of closed cymbals on the side of the kit. And then the length of the line corresponds to how hard the cymbal was struck. So I set up objects for every drum and cymbal that will return these SVG elements for us to render. So remembering back to that 3-element data array we saw at the beginning, whenever that first element in the array, which corresponds to the event type, maps to the hi-hat event trigger, this makeShape method is going to fire and return us the SVG element for us to render. So to make the shape more dynamic, I added in a rotation angle that increments each time the cymbals hit, and then I'm just calculating a new X and Y position that represents the end of the line. And then ultimately, we're going to return that SVG element for us to render using those coordinates that we calculated before. So after setting that up for each drum and cymbal, I've got a visualization that you'll see here in this next clip. Just wanted to give a quick warning. This demo does contain flashing shapes and light, so if you have a sensitivity to that, I would suggest just listening to the audio portion. So what I touched on today barely scratches the surface of what's possible with MIDI in general. To recap, MIDI specifies the communication protocol over which we can interface with electronic musical instruments. And then the Web MIDI API allows us to tap into those MIDI messages and interact with them in a web browser. There are barely any apps or tools built using the Web MIDI API that I could find online, meaning there's a ton of untapped potential for useful apps for the music community or just plain old fun side projects. So I just wanted to say thank you to the CascadiaJS team for helping and providing feedback throughout the summer, to the W3C audio working group, who are the creators of the Web MIDI API, and of course, everyone who's put up with my music over the years. I hope this inspires some of you to build some cool projects using MIDI and the web. Thank you.
Bravo! Scott, that was awesome. Thank you so much for that. A bunch of people in the chat are just like, dang, no questions, just drum solos. That was so. Oh, that's so sick. That's like getting me back to my music roots back when I did stuff like this, and now I kind of want to get back to it. That's so neat. For people who want to play with this themselves, is there a framework or anything that you recommend that abstracts the Web MIDI API that makes this kind of visualization stuff even easier?
Yeah, so it's that would help you get started with some of the mapping stuff. As far as visualization goes, I don't think there's any libraries out there, but that's sort of what intrigues me about this is that there's very few projects that have used this so far that I could find. So I think there's just a lot of opportunity for people to mess around and make really cool stuff with it.
Yeah, I could see some really interesting like GSAP demos with it, being able to make some cool animations that go along with it, which would be really awesome.
For sure, yeah. It reminds me
have...
back to like the old iTunes visualizer days.
Yeah. Oh, good times. That brought back some memes. Do you have any like takeaways or key bits of advice that you'd give to someone who wants to get started with this?
Yeah, I mean, I think integrating hardware and software is really hard. So I think just starting small and messing around and finding what works and then building on that. The first thing I started with was just trying to get anything out of that little keyboard to show up in the browser with vanilla.js, and then just slowly building on that. So I think, just starting small and improving from there for sure.
And we've got some questions coming from the audience. How might you approach this for something like a string instrument, like basses, guitars, and other ones?
Ooh, so that's tough. I think there are some pieces of software or actual hardware like guitar pedals that can transmit or translate the audio signals to a MIDI signal. So that's definitely possible. There are actually some woodwind instruments that are MIDI instruments, which is kind of cool. I've never actually seen them played before, but they're just a digital, like clarinet or whatever,
wait, I've seen
and it
like
transmits
the
MIDI.
Akai something. They've got one where it's like almost like a saxophone, but not.
Yeah, right.
I kind of want to play with that. I've seen some electric or electronic guitars where it's like buttons up here, and then there's different strings that point into some kind of interface and stuff. I wonder if there's a way to natively do that. I'm intrigued.
Yeah, there could be.
Well, once again, thank you so much, Scott, for being here. This was such a fun talk, and now I want to play with things now. That was so great. But again, thank you again for being here.
Yeah, thank you, Cassidy.
Cool. Well, now we're about to go into our break, and so I was requested to do jazz hands. Let's go.